Imagine a world where diseases like cancer, sickle cell anemia, and even aging can be eradicated, not treated but cured, by editing an individual's DNA. Welcome to 2025, the age of genome editing technologies. From curing genetic disorders to altering crops for sustainable food production, genome editing tools like CRISPR have unlocked the abilities once restricted to science fiction. But here is the billion-dollar question. Where do we draw the line? Who gets to decide if editing genes is ethical? Should we play the role of nature or God when editing the genetic fabric of life itself? In this video, we will uncover the latest breakthroughs in genome editing in 2025, analyze their ethical implications, and explore their future applications from medicine to agriculture and even the concept of designing humans. Stick around because we are about to share not only the promise but also the dangers behind this revolutionary science, the incredible advances in genome editing by 2025. Let's kick things off by highlighting how far genome editing has come in the last few years. The science has evolved rapidly from crude tools to extremely precise molecular scissors. Here is what's new in 2025. Number 1, CRISPR-Cas9. CRISPR has undergone a massive transformation. Scientists have developed prime editing, a technique that allows edits to DNA with amazing precision, inserting or deleting genetic material without introducing errors. Prime editing can fix over 89% of known genetic mutations linked to diseases like cystic fibrosis, muscular dystrophy, and even rare cancers. Next, base editing. Editing genes without cutting DNA. Base editing in 2025 has matured into a game changer. Without introducing double-strand breaks, we can now correct single genetic spelling errors. For example, in genetic conditions like sickle cell anemia, a single mutation can now be corrected safely, reducing risk of harmful side effects. CRISPR, Cas12 and Cas13 for RNA editing. We are no longer limited to DNA. Cas13 lets scientists edit RNA in a real time. Why is this important? Because RNA-based therapeutics can have a temporary effect, meaning fewer permanent risks. Next, genome editing in embryos, a reality in 2025. While controversial, researchers have started exploring the potential for editing embryos to eliminate heritable diseases. Since germline editing affects future generation, application has raised significant global debates. Future applications of genome editing. Genome editing technologies are being applied across critical industries. Here is what the future looks like. Number 1, transforming medicine. So think, what if we could cure diseases before they occur? Genome editing has already begun revolutionizing healthcare. Genetic age-old enemies like Huntington's disease and Tay-Sachs might soon be solved permanently. Next, scientists genetically reprogram immune cells like T cells to attack and destroy cancer cells. Furthermore, genomic technologies in 2025 have introduced therapies to slow or even reverse aging, targeting faulty mitochondrial genes or sense-specific genetic pathways. Number 2 is revolutionizing agriculture. Farmers are benefiting from genome editing in agriculture at an unprecedented level. By editing the genes of wheat, rice, and corn, researchers have created crops resistant to pests, drought, and extreme temperatures, ensuring global food security. Moreover, nitrogen fixation. Imagine crops like wheat or maize that can fix their own nitrogen from the atmosphere, cutting down on fertilizer damage to the environment. Next, edible vaccines. Scientists are engineering foods rich in vaccines, like a banana infused with oral doses of the measles vaccine. Don't you think it's wonderful? Gene drive technologies to combat pandemics. Gene drives modify insect populations. For instance, targeting mosquitoes to eliminate malaria or dengue without affecting ecosystem. Next is designer humans, brave new world or slippery slope. And here is where it gets divisive. Imagine A parent in 2025 being able to choose their child's genetic traits, enhanced IQ, resistant to diseases, physical attributes, and even athletic abilities. The ethical dilemmas of genome editing. While the science is exciting, the ethics surrounding genome editing are anything but simple. Let's break down the biggest ethical concerns. Number 1. Unequal access. Editing genes isn't cheap. There is a growing fear that wealthy nations and elites will benefit disproportionately, leaving poorer regions behind. Would genome editing create a genetic upper class? Imagine a world where only super enhanced individuals thrive, while others are pushed further into inequality. Next, germline editing for human embryos. Editing human embryos today affects the genetic makeup of future generations, forever altering the human gene pool. Who decide what's worth editing? Preventing diseases like Alzheimer's may seem ethical, but what about editing for better looks or IQ? Would this become another form of eugenics? Next, playing God. Critics argue genome editing gives humanity too much power. Should we be intervening in nature's blueprint? A philosophical divide exists between those who see humans as ethical stewards of this technology and those who believe it's overstepping natural boundaries. The global regulatory landscape in 2025. Regulation has struggled to keep up with the pace of innovation. Here is how the world is addressing the genome editing revolution. Global Summits on Human Gene Editing 2025. Unified frameworks are being proposed, ensuring countries establish safeguards to avoid misuse. Different national guidelines. Some countries like China continue exploring bold genome editing projects, while nations like Germany enforce strict bans on germline editing for ethical reasons. The question remains, should there be a global regulatory body for genome editing policies? To summarize, genome editing technologies by 2025 offer unprecedented opportunities in healthcare, agriculture, and environmental science. However, the ethical implications, unequal access, germline editing controversies, and genetic eugenics must be carefully navigated. Further success depends on striking the right balance between scientific ambition and global responsibility. Now, question for you. What do you think should be the limits of genome editing? Should we embrace full control over genetics or establish strict boundaries to avoid misuse? Comments below. I would love to hear your perspectives.